We want to look at some of the key terms when we are having looked at the definition of probability. We want to look at some of the key terms that are related to probability. Throughout this particular session, we may be able to mention some of the words. So it is very important that we understand some of these key terms. And one of the key terms is what we call random experiment. Now, this is an experiment that has a known set of possible outcomes. And it is called a random experiment if it cannot be predicted in advance which specific outcome will occur on a given execution of an experiment. So, for example, we are looking at tossing a dice, or we are looking at tossing a coin, or we're looking at card draws from a deck. So we're saying why we're calling it a random experiment. For example, a dice has about six sides, about 6 sides. So meaning the random experiment, the outcomes are from a dice. The outcome can be 1, the outcome can be 2, the outcome can be 3, the outcome can be 4, the outcome can be 5, and the outcome can be 6. So that means that in a random experiment, you would have to predict the chances or the possibility that one of the outcomes can come. And that's why we call it a random experiment, because you cannot definitely say that the outcome will be 1. So it has a set of outcomes, a set of possible outcomes, and that makes it to become a random experiment. 2 is the term outcome. The result of any random experiment is what we call an outcome. So we suppose that when you toss a coin, for example, you can either get a head or you can get a tail. So when you toss the coin, the head is the upper surface. So tossing a coin is a random experiment that results into an outcome that is called a head. So the outcome of a head becomes the when you toss the coin, uh, which is a random experiment because it has a set of possible outcomes. Uh, when the outcome finally occurs, it is a head, and if it is either a head or a tail, and therefore those particular results of the experiment are what we are calling outcomes. Thirdly, another statement is another key statement is what we call a sample space. So it is a set of all the possible outcomes for a random experiment. All the set. You should be able now to understand the statements. We're moving from a random experiment to an outcome, and we're now moving to a sample space. And on that combination of the outcomes from a random experiment is what we call a sample space. And we're saying that obtaining a head or a tail on tossing of a coin is possible. And therefore, the sample space for tossing a coin is either a head or a tail. So the head and the tail are the sample space for tossing a coin. And similarly, if you roll the dice, uh, or if you roll the die, there are different outcomes. So we can either get 1, 2, 3, 4, 5, or a 6. So therefore, the sample space for rolling a die is 1 to 5, or I mean to 6. The other key term is what we call equally likely outcomes. Now, events with the same theoretical probability or likelihood or occurring are referred to as equally likely events. For example, the relative occurrences of a head and a tail on tossing a coin for a very large number of tosses are equal. So head and tail are equally likely outcomes that make the tossing of a coin fair and unbiased if it's to decide between two options. So we are saying that a dice, I mean a coin, has equally likely outcomes because it has two outcomes. It is either a head or a tail. And therefore, whether you tossed it for 3 or 4 times, the chances that the outcomes will be equal are the same, because there are only two options. Apart from a dice where you could, in one toss you can get a 1, another toss you can get another 1, another toss you can get a 2, another toss 3, 4, 5, and 6. However, for equally likely outcomes, there are only two. Uh, there are only two outcomes. For example, in volleyball, there are only two outcomes. It's either a win or a loss. So this is what we call equally likely outcomes. So another key statement that we need to look at here is what we call an event. So in the case of a random experiment, an event is a set of possible outcomes at a specified condition. For example, when you roll a die and 4 is not obtained, this event is the random experiment that is rolling of a die whose result is not 4. Therefore, this event has 5 possible outcomes that are 1, 2, 3, 5, and 6. So, suppose it's mentioned that event F is equal to obtaining a black card while drawing a card from a deck of 52 cards. In this case, event F has 26 possible outcomes. So in this case, the event F itself has 26 possible outcomes because there are 26 black cards, a total that is 13 spades and 12 clubs. So we are looking at the event that is going to occur. So like when we were defining a random experiment, the number of outcomes occur from an event that occurs. For example, throwing a dice is now an event that has occurred, and therefore, uh, the outcome occurs definitely when, for example, when we're saying here that the event is a random experiment that is rolling of a die whose result is not 4. So if the result, if 4 is not obtained, then it means that the rest of the outcomes are very possible. So it will either be a 1, it would be a 2, or it will be a 3. And that is what we call an event, uh, uh, an, a random experiment that occurs becomes an event in that regard.